comparing data displays in dot plots. So specifically, this is going to be about dot plots. And there's a real important term here, comparing the displays. So we're going to be looking at more than one dot plot when we compare them. We're going to compare the data in one to the other, and there's going to be a specific way we do that. We're going to start by looking at just one dot plot. So we're not going to make a comparison yet, but we're going to talk about what we really look at to make the comparisons. And the first thing we're going to look at is the shape of the data in the dot plot. The second thing will be the center of the data in the dot plot. And the third thing would be the spread of the data in the dot plot. So these are the three things we're going to look at, and then we use these to compare data into dot plots. So what do these refer to? Well, shape is how the data is arranged, and we'll do an example in a second, but how the data is arranged in the dot plot. Center would be the median or the middle of the data. Where does the center or the median of the data seem to be in the dot plot or each of the dot plots if you're comparing them? Spread, finally, is really the range of the data or the values that the data is located between. So we'll look at that real quick. That can be an easier one to find, but you're really looking at kind of the range of your data when you look at spread. So I got a little extra space, and we're going to go ahead and fill out these three and make a quick little observation about this. Now, some of this can be broad, which means you can actually come to a couple different conclusions on your observations, but you want to really look at your data and kind of look at what it's saying. Where's the data concentrated? Let's look at the shape first. So the shape is how the data is arranged. Well, if you look at the data we have on this dot plot up here, really it's pretty evenly spread out. 31 has the most right here, but other than that, basically twos or ones on a lot of the numbers. We don't have a large concentration like in one area. If we did, we could say that the data is concentrated, between 33 and 35, but it's really not. So we're going to write that the data is evenly spread out. And that won't always be the case. Sorry, this program doesn't write perfectly, but there it is. So data is evenly spread out. In this case, it's pretty evenly spread out. Again, that won't always be the case, but in this one it is. So now let's move on to the center of the data. So in center, we're looking for the median, or we're looking for the middle of the data. Well, I circled it earlier, but the data, the real median tends to be where you have kind of your concentration of numbers. 31 is where we have the most of the numbers, and really between 31 and then you could probably include 30.5 or 31.5 right there if you wanted to. But I'm going to say that the median or the center of the data is that most dots occur at 31. So that's a quick little observation about this dot plot. Thirdly, we have the spread, which talks about basically the range or the values that the data is between. Well, the beginning of our data is at 28, and the end of it's at 35. So essentially, we could say basically two things about our data. We could get the range, and that's basically 35 minus 28, which I believe gets you 7. So you could say that the range equals 7. And you could also add another one. We could put a second one, and this I've seen before too, that the data is really concentrated between 28 and 35. So say most of the data, let me put it this way. Most of the data actually, even though the range is 7, most of the data falls actually between 29 and 34. You have this lone 35 out here and this lone 28, but most data is between 29 and 34. So, and I'll put an and sign here just to make it easy, but that's another way you could talk about the spread. You could say range, but it could be like an answer choice where they say where's most of the data concentrated. So this is how we can make an observation. So then what if we have two of these? So we're really just going to make a comparison. We're going to look at this set of data. We're going to look at this one. How are the shape, center, and spread maybe similar or maybe different? So let's try that real quick. It says the dot plot shows the heights of 15 high school basketball players and the height of 15 high school softball players. So softball is right here, basketball is right here, and let's talk about the shape first. Remember, the shape is going to be how the data is arranged. Well, initially to me they look kind of similar, really. They're not totally different, but one thing sticks out. If you look at the heights right over here, actually our data is a little bit different. And as you would kind of expect, the basketball players actually have or are taller. Essentially, you could say that the basketball players are taller than the softball players because you can see where the data falls. So that's a quick little observation we could make about the shape of the data. So I would say basketball players are taller, that's an A by the way, than the softball players. And that's just by looking at the numbers in the inches in the bottom part of the dot plot right over there. And that's a quick little observation we can make about the shape. So then what about the center? Well, where's the center? The center for softball players is really around about 5'4". The center for basketball players is more around 5'8". So we could write a long sentence if we want, but basically I'd say the center, I would say right over here that the most common height for softball players is 5'4", and basketball players is 5'8". So I won't write a long sentence, but we could say basketball players five eight, comma, looks like a period, but it's a comma, softball players 5'4". So not exactly the same when we have that. Finally, we talk about the spread. How's the data spread out? Well, even though the numbers are different, we basically go from the first dot here is what it looks like to be about 4 feet, maybe 4 feet 11 inches right there, and we go to 5'6". And if we talk about the range, 5'6" minus 4'11", I think that gets you about 7 inches of difference right over there between the shortest and the tallest softball player. If you look at basketball, you got 5'2" all the way up to 6 feet. And remember, 6 feet, that's basically like 5 feet 12 inches. So the 10-inch difference over here. So in the spread, the difference in the comparison between the two, basketball players, we could say basketball players basically have a greater spread in height. So basketball players have, that doesn't look very nice, have a greater spread in height. So the most important thing about this is just being able to look at this data and make the right kinds of observations. You could write these sentences a little bit differently, and a lot of this might be dependent on some multiple choice answers, but being able to compare two dot plots and look at them, I guess, is essentially what I'm saying, and then being able to compare kind of similarities and differences between the shape, center, and spread.